So today we're going to implement our own linked list class, but we're going to make this a little bit simpler than the Java standard library linked list class. Um, so a couple of simplifications we're going to make so we can focus on core ideas and not get sidetracked. Our linked list class is not going to be a generic, meaning we don't have the angle brackets here where we can specify the different types. So Java used not to have generics. So before Java 5, there were no generics. So we're kind of going old school linked list class here, where all of our values we add to the linked list will be of type capital O object. So that's one simplification we're making. The other simplification we're making is that our linked list that we're going to implement together is a singly linked list and not a doubly linked list like in the Java standard library. So we're going to be able to have methods like has next and next, but we're not going to take time to implement things like has previous and previous. So these are some of the simplifications we make. The biggest conceptual thing that we're going to start with here is that now that we're implementing our own linked list class, there's more involved than we ever had to worry about before in chapter 15 when we just used the Java standard library one. And so one term we're going to focus a lot more on now is that a linked list is made up of nodes, and nodes reference the values that are stored in the linked list. All we ever really focused on last chapter were the values, but now we're very much going to focus on the nodes because it's the nodes that are linked together to make up the linked list. And each node has so back to this terminology like is a has a type stuff. Each node has the reference to an object that's the actual value stored in the linked list, that particular element. So we're going to skip over, we're going to come back and fill in like the constructor and some of these other methods. We're going to jump down here where it says class node. And we're going to create an inner class. So we're inside of the linked list class, and this class is public. You can put classes inside of classes in Java. And that's an example of encapsulation because this node class that we're about to write, no one else needs to directly reference it. So we're going to, other than the linked list class, so we'll define it as an inner class, and that way it will be nicely encapsulated, and it's only for our use. So you're going to see some differences here. First of all, we're going to make it marked static. If we have time, we'll get into why that is, or at least I'll share with you some resources. And this class is going to be called node. Normally, when we make a class in Java, we have instance variables. They are private. We have accessor and mutator methods to access those instance variables because that provides encapsulation. This class is only ever used, the node class is only ever used in the linked list class. So we don't need to worry about encapsulation. We don't need to write accessor and mutator methods. We're simply going to make the instance variables public because public in this scope is only within this linked list file. So we're going to say public object data. Data is the instance variable that refers to the value being stored in the node, the value that we're adding to our linked list, okay? But we need more than that. This is, in order for this to be a linked list, each node has to reference the next node in the list. So our second instance variable will be of type node, and it's called next. If we were to do a doubly linked list, we would add a third instance variable of type node, which would be called previous. But we don't really need to worry about that. It's really not that tricky, to be honest. So here is our node class. It's super simple. A node in a linked list simply contains two references, one to the data, the value stored in that node, and one to the next node in the list. That's it. Okay. So this is done as our like little private inner class here with public instance variables. One thing that is more conceptually challenging in this chapter compared to the last chapter is in the last chapter, we had the linked list itself, and we had a variable that referenced that object. And then we had elements in that linked list or values in that linked list. Now we're adding a third concept at the same time. We still have the linked list object itself. And of course, we still have the values, the elements, the data is what we're referring to it now, that's stored in the list. But now there's this new concept of the node. And so as we're writing code today, and as you're writing code on Thursday and throughout this chapter, we need to be really clear, like, are we focused on the list object as a whole? Are we focused on a node, or are we focused on the data? There's three different objects at play here, three different classes at play, and that can get tricky. But we'll take it slow and we will figure it out. So this is our private static inner class right here. We are going to reference this class inside of the linked list. So again, the linked list class is the class that represents the entire list, the whole thing. So it needs an instance variable that we can use to get to all the nodes in the linked list. So let's write the instance variable first. It's going to be private because now this is a public class. We want to have private instance variables. We want to have accessor and mutator methods. We need that encapsulation. The type is node, and it's called first. So in the linked list class, the instance variable first will refer to the first node in the list. If we were doing a doubly linked list, we'd also have an instance variable called last, and it would refer to the last node in our linked list. But we're going to stick with this. So let's explain what this is. First refers to the first node in this list. If the list is empty, first is null. Cool. I'm going to try to be very specific with my terminology in terms of, am I talking about the list, the node, or the data? If you feel like I'm not being consistent and specific, please call me out, so I don't want to confuse anyone. This is the only instance variable in our linked list class. That's it. All the linked list class itself is, in addition to all the, from a data perspective, is just one reference to the first node in the list. That's it. Okay. All right, let's implement a couple of these methods, and then I'm going to show you some pictures, and we'll implement some more methods, and we'll go like back and forth. But let's start with the constructor. The constructor constructs an empty linked list. So when we write a constructor, we want it to be public. The name of the constructor, as a reminder, has to match the name of the class. This is the default constructor, so it takes no parameters. And then we'll simply say this dot first equals null. This line of code is technically not needed, right? Instance variables by default are initialized to a null, zero, false value. But here, I think it's useful to explicitly say this dot first equals null to clearly communicate when we make a new linked list, that list is empty. It has no nodes. And so therefore first is null because that's how we specify we have an empty list. As we implement our linked list, we are going to try to implement it in a way that is consistent with the Java standard libraries linked list. So we're going to call our methods the same name as the Java standard libraries linked list methods, and we want the behavior to also be the same. And so the next method we're going to implement here returns the first element in the linked list. And so hopefully you remember that method is named getFirst, and it's going to return the data stored in the node. So the return type is object, and the method name is getFirst. This is where it starts to get tricky. When we invoke get first, this is a public method on the linked list class. It needs to return a reference to the data stored in the node, not the node itself. In fact, the type node should never show up like in a method header for a public method because node is internal to this class, right? We can't let it leak out. And if we did, like, no one would be able to use it anyway. So like if we had node here, this wouldn't even compile. So this is where we have to be careful. Get first returns the data in the first node. It doesn't return a reference to the node. And that's a really important conceptual difference. We also want to follow the behavior of the Java standard library. If the list is empty, does anyone remember what happens if we call get first on an empty list with a Java standard library linked list? Absolutely. So we're going to do the same thing. If this dot first is equal to null, we're going to have to make a new no such element exception. That makes an object of that type, and then we're going to throw it. This might be the first time you've ever made an exception and thrown it. But we're going to do a lot of that throughout this chapter as we're implementing these data structures. So an exception is an object just like any other object. So we need to make a new one when we want one. And there's all these different exception classes. Exception is like the parent class or a super class up there somewhere, but no such element exception is a specific subclass. So we're going to make a new no such element exception, and then we're going to throw that with the throw keyword here. When we throw an exception, code in this function stops running. So here, let's finish the function. Return this dot first dot data. Again, part of the challenge here is we're going to have lots of levels of direction as we're referring to different instance variables. This refers to this object. Dot first returns to the first instance variable up here of type node. Dot data refers to this instance variable within the node object. So this dot first dot data returns the data in the first node of this linked list. Ugh. But back to the throw, when we throw this no such element exception, this line of code will not execute, okay? The way the Java runtime works is that the next line of code that executes will be whatever code that called somewhere up the call chain that has a try catch block. And we have written some try catch blocks before, and we'll do more of those. But somewhere up there, there's a try catch block. And if we didn't write it, then like eventually it'll be caught by the Java runtime and our program just crashes, right? And we've seen that plenty of times. So here's what get first looks like. All right, now it's time for some pictures because we're going to implement remove first. And you might remember that remove first returns a reference to the data that was just removed from the list. So it's going to return of type object. But before we implement this, I think it's helpful to look at a picture. I don't know. Let's insert before we remove. Just kidding. We'll come back to remove first. I don't know why I put that one first. I'll be completely honest with you. Let's do add first instead. So public void add first. Again, the same method name as in the Java standard library. It takes one parameter, which is a reference to the element to add. I think it's helpful for us to conceptually understand how we add an element to the beginning of a linked list before we focus on removing it. So here's a picture of inserting a node that's from our textbook. And it breaks it down into 3 steps, and we're going to implement each of the 3 steps in turn. So here's what our linked list could look like hypothetically before insertion. So again, with these like diagrams, this shape, rounded rectangle, represents our linked list object. The only instance variable in the linked list object is a reference to the first node. This rounded rectangle represents that node object, the first node object. It has two instance variables, the data, which in this case is the string Diana, and a reference to the next node, and on it goes. Like this could go on for quite some time. We want to insert a new element. We want to insert the string Amy at the beginning of this linked list. And so that requires 3 steps. First, we need to make a new node object. We have a reference to the data, we have the reference to the string Amy, but we have to make a new node and we have to initialize data in that new node to refer to the string Amy. And then we will eventually have to do something with next here. So step 1 is to make a new node object and initialize data to the element that's passed into the add first method. The second step is we need to link this new node. So we'll have a variable called new node that refers to this node object. We have to link this new node to whatever is the current first node. And we can do that by setting next to reference the first node. That's step 2. Step 3 then is to change the linked list object such that first refers to the new node because the new node is now the first node. And so we need to refer to that as we go. An additional complexity that we're going to see as we implement these methods throughout this chapter is that the order in which we do these is critically important. Okay, so imagine if we swapped steps 2 and 3. If we first said first equals new node, so we updated this reference first, and then we tried to update next in this node to this node, we've lost this node. We have no reference to it. It's gone because the only reference we have to this node is back when first was referring to it. So the order in which we do these operations is critical. So let's try this out, these 3 steps. And in the comments, I'm going to call out each of the 3 steps as we go so that you can look back at this code and look at the diagram and make those connections. So step number 1 was to make a new declare a new variable called new node of type node and actually make a new node. And then initialize the data instance variable in that new node to the element. So the element is the element we're adding to our list. Data needs to refer to that. It's all of type object. Step 2. Step 2 is we need to update next in new node, in the node referenced by new node, to the node that is currently the first node in the list. New node.next equals this dot first. Finally, step 3, update the linked lists first instance variable to refer to the new node because now it is the first node. So this dot first equals new node. We wrote 4 lines of code, and this is going to be something we see over and over again in this chapter. We will not write a lot of code, and our brains will really hurt because it's really conceptually challenging to wrap our heads around all of the indirect or all of the references on top of references and the order in which we have to perform operations. So it's not the amount of code we have to write that is challenging this chapter. It's figuring out all of these references and doing things in the right order. All right, let's go up and implement remove first. Again, I'm not sure why I put it in the wrong order, but that's okay. Remove first, what's that look like? Here's our linked list. The linked list object has an instance variable first. It refers to the first node in the linked list. That has some data. It has an instance variable next, which refers to the next node in the linked list, and so on and so forth. When we want to remove the first node, the way we do that is relatively straightforward. We simply can update the linked list objects first to refer to the second node in the list. Conceptually, what makes that challenging is how do we get to that second node? Well, first gets us here, first dot next gets us here, and that's how we find the node. So again, conceptually challenging, not much code to write at all. But we have to check for error conditions. So if this dot first equals null, we do the same thing we did before, throw a new no such element exception, just like the Java standard library. Before we change this dot first, we need to remember what is currently the first node. So we have to hold on to that in a local variable. So our element that we're removing is this dot first dot data. So again, all the dots. This refers to the first node, and in the first node, get its data. Store that in a local variable of type element, because we're going to return this in a moment. But first, we have to say this dot first equals this dot first dot next. And then we can return the element. Again, only 3 lines of code. But look at how many like dots we're using to move through these different objects that we're referencing. That's what makes it tricky. Okay, we're going to pause here.